practices. AC water also we are started reusing it. AC waste water. So that kind of see whatever the waste is coming out of from the industry. Hello, sorry. Whatever the waste is coming out of from the industries, I think a lot of meeting, a lot of seminar, webinars. I used to say, so milk cover is one example I give normally, because milk cover coming from the household, it is again going for the industry, and they are started reusing it to making the tarpaulin as one of the raw material they are using it. So even in fact, PET bottles, plastic PET bottle also like that only. Plastic PET bottle. Hello, are you hearing? Hello.
Yes, sir. Yes, sir.
Yeah. So in the PET bottles, it is a plastic PET bottle. It will not get composed at all, even if it is a 500 years or 1,000 years also. Instead of that, we can start reusing it. So one of the industry from the Tirupur, he started reusing it because he's making a T-shirt. In that, one of the raw material, say 5 to 10% as a raw material, they are using the plastic material. So like that, lot of waste product can be converted into useful product. So that is possible. Even I normally I used to go to the temples. Wherever I go, I used to go to the temples. I used to carry the yellow bag or whatever, because we go to the function, they give some bags. So that I will try to use. I will not be using plastic bag at all. So maybe that also we can start practicing it. So industries, even if it is a 20, 30 industries, start using it. No, at least we can save something. Because when we go to the function, they give some in marriage or function we go. They give nowadays everybody started giving good quality of bags, so that you carry and go for whenever you're going for a temple or whenever you're going for a purchase kind of vegetables or flower. So you can make use of that. Don't try to avoid at least plastics. See, one by one we can change the thing. See, I almost started 2, 3 years back. It was regularly I am doing that. In fact, whenever I am going for a Tirupati, I used to carry this bag. And whenever I am going for a Tirupati, I used to buy their agarbattis, because that agarbatti made by flower. In Tirupati, they have put recently. Hello, sorry. Because since I am talking in the mobile, I am getting some calls. Sorry for that. So in Tirupati, they put a second plant also for making the agarbatti. So it's a good thing. So that is why I used to buy them and encourage them. So even people are buying it regularly. So I am also started using that. And thanks for listening all these things. Maybe we can at least somebody can start using this kind of alternate. No, it will be useful for the society. So that is my idea. And today we are also going to see our waste to fuel. Mr. M. Suresh is going to talk about it. Let us listen from him and learn from him also. At least we will try to implement in future if possible. Thanks, industry members, and thank you, sir. Over to you, Mr. Bala.
Yes, sir. Thank you, sir. Thank you, sir. Welcome. Thank you for your welcome address, sir. So without any further ado, we start our session with the day of introduction of our speaker, Mr. M. Rajesh, working as a CSO Smart Manufacturing at Metasys Technology Solution. He has 20 years experience in capital equipment and 14 years experience in additive manufacturing, specialization in sustainable solutions, green technologies, and building India's AM ecosystem. So thank you for our invitation to accept our webinar, sir. So if we come to the sir, you can start the session, sir.
Yes, thank you, sir. And is this slide visible?
Yes, sir. Yes, sir.
Okay. So thank you. I would like to first start off by thanking Mr. K. Bhaskaran, Chairman IWMA, and the members of IWMA who have been kind enough to give me this opportunity to present in this forum. And today, with his inaugural address, I have noted few key points, which I would like to just talk about, which I'm also going to talk about. The main point is the rural-urban connect. He talked about the urban cities giving power to the rural villages, but now from rural it is coming back to the city. So we will be talking about how we can connect rural to urban to make sure that we have a complete system ecosystem, a complete cycle maintained for the benefit of everyone. The second thing which he talked about was the plastic packets being used by industry in a textile industry. Now that talks about the complete circular economy, which means that the waste which is going from the industry to the common person, to the human, the common person who is using it, it's going back to the industry and being used as energy. So this is a great example of circular economy, which is also the need of the hour today, which we are going to talk about. And the third about the conscious effort of not using plastic but using the bags which we used to get. So this is the third important point, that the conscious effort is not by just the government or by an association or by an organization, but it's more about individually how we take that conscious effort to maintain and understand what sustainability is and how we should go forward. So, we have different ideas about sustainability as such, because we talk about carbon neutral, we talk about ESG. Industries talk more about carbon neutral, ESG, and waste to energy. But normally I've seen in the industry that it is maintained at the top level or probably in the senior middle level. The lower level is really not very much conscious about it in a large extent, except if they are in that department. So what we would like to do is, create a complete awareness to every person working in an organization from top to bottom, right to the cleaning person, right to the loading unloading person, as to how sustainability has to be maintained. And this is very important for us as India, as Tamil Nadu, and it's this is what the base should be for us. In fact, our culture has always taught us this. Whatever we use, we used to recycle. Our culture has been rich with that. And but somehow, over the period of years, with the industrialization and with colonization, we have forgotten that basics. And now we are talking today about the same, in a different way, manner. So however, it's the order of the day. We have to talk about it and we have to address this and take a conscious effort to that. So I will start my session with the global carbon and ESG dynamics. See, very importantly for industry here, most important is the balance sheet, the profit and loss, and sustainability comes at a cost. Everything comes at a cost for an industry. It is not easy to set up a facility which will be take recycling, because that recycling again has to be reused, and how efficiently it is reused, and whether that it is actually giving a return on investment is also an important part. But we should be also aware that beyond the usage of this solutions within our industry, there is also a global carbon and ESG dynamics which is working on towards us. As we all know, we have been manufacturing for the world always. We have been manufacturing for us, but our imports exceed our exports. But slowly, what we are doing is we are manufacturing for the world, and now we are making in India. So naturally, when exports start building up, there will be certain dynamics which will be falling on us. And actually, it is in a way good, because just to let you know that recently there was news that Sweden, they are smartly importing waste from other nations and using it for sustainable solutions. The reason being that they do not have enough waste. Now, this is a very tricky situation to be in, because India, we can never be that way, because with the population we have and the amount of waste we have to manage. But this is what is the West doing very smartly. And right now, I am in Tirumadi, and just outside my window, I can see a huge heap of plastics lying there, untouched, and just heaping on. and we can see this right across in our many cities. We always wonder, why and where it is coming from. Of course, we have to understand this is all coming from industry as well. If a chips packet is manufactured somewhere, a chips is manufactured, it goes to an end user. The end user uses that chips and he throws the packet. Who is responsible? We all are responsible, of course, but the industry is also responsible about it. So we need to take a conscious effort of understanding this and the waste in such a way that we aggregate and we use this waste to energy. And it's today the discussion is not about just doing social service. Today we are going to talk about how this can mean money for all of us, including everyone. I know that many industries, I'm really, happy to see that there are around 3,000 members in IWMA, and it's great. But, and many of them, the large companies, medium companies, even smaller companies who are conscious about it are making strides towards it. But we do not know whether it's a right stride towards sustainability. Is it going to be economical? Many of us stop because it's not economical, because there are so many ideas. Like we put up a solar panel and then we say, okay, it's not working for me. We put up a windmill and wind is just like 30% efficiency load. So we have such challenges. So today we will talk more about that. And yes, I am also learning in this because I'm not an expert on this, but I have been having an expertise in involving into applications in industries, in various industries with various products and solutions. So we will deep dive into each product and each session, and global carbon and ESG dynamics will start with going into the energy challenges into industries, uh, where we will talk about our own industries. What are the challenges we have in terms of energy? Now, this is important because when we have an external factor and an internal factor, I'm sure that we have to look at options which will help us make ourselves energy neutral or probably energy surplus in many ways. And then we will talk about the waste to fuel pathways, the pathways which are there towards waste to fuel and waste to energy and waste to money, I would say always. And fuel forms and its applications. There are various type of fuel forms and what applications. We will not be able to get into too many applications, but few industrial applications. We can always discuss this further industry wise, because it's a very deep, discussion as far as, because the industrial waste with each industry is different. Industry waste within each industry in different divisions of theirs is different. So we need to understand that before we get into the application part. And circular economy integration is very important. Circular economy is just not within the industry but outside the industry, and we need to look at it in a larger scale. uh, and way forward for industries, and then a small introduction about our company and conclusion. So I'll just start with the cause. Now, for us, if most of the industries in India or anywhere, where there is a surplus sort of waste which is coming out, the disposal has been a problem for us, and the amount of disposal keeps on adding. We have some systems in place, but most of us do the landfill. That's the basic thing which we do. We go in for landfill, which we feel that it's safe, and then we just dig and put it inside and say, okay, everything is fine. But we do not realize that the causes is that there are metals and chemicals which slowly get into the soil, and they get into the land and into the trees which we and the plantations, and it gives a different it really impacts the flora and fauna and also the minerals which are around us. And then it also, in terms of solids, it gets into the ground. In terms of the gases, it goes above the ground, which means carbon dioxide and methane is formed, and which is not visible to us. But what is visible is are the disasters which we see. And when we say that sitting in here in Chennai, that if I am emitting something and nothing will happen the other side of the globe, I think we are wrong. There is a connection between everyone across the globe, whatever we do. So we need to first of all be conscious of that. whatever we do, we need to be conscious. Whatever we emit or recycle or even dispose, or even we dispose of, we need to see the larger effects. And the larger effects we will not see, our grandchildren will see. So if not for the nation, for the globe, for the country, for anyone, at least for our own grandchildren, at least for our next generations, let's keep this, understand this, that this is what will happen. And with the ongoing activities, it is only compounding. It's not 1 plus 1 is equal to 2. It's going exponentially. Now, that is the cause, and the effect of landfill is that the water pollution, air pollution, soil pollution, natural environment is going into a disaster. We can see a lot of birds, uh, vanishing, animals probably in the vanishing stages. We ourselves are having so much trouble health wise. We do not realize that this is because of the air pollution, water pollution, and soil pollution which comes in. We talk about even our fruits, the vegetables which we eat, and the water we drink is contaminated to a larger extent. While this is one side of the story, the other side is that I'm trying to talk about the push which is there from the global side of the market. So this is basically also good news for industries, because the more we get into sustainability, the more promising and the more profitable it is going to be coming in the coming future, because the West has polluted so much that they have to go sustainable. And it's like a cycle. We were not so much of polluting. They were polluting much. They had all the industries. They pushed all the industries to India, Africa, and few other nations, Southeast, Middle East. And now they are talking about sustainability. Now, the idea is that how do we push sustainability and make sure that the we keep our environment safe and reduce the carbon emission, is by giving some sort of carbon credits and some benefits to the industries. So there is a mechanism in place already globally for pricing and trading greenhouse gas emissions, and it has got two key segments. One is the compliance markets, which is driven by government regulations, and this through the suppliers, probably the customers. So the end customer, if he's a say a company who is from out of India, it's a MNC. They have certain systems which are there as per the EU emissions, etc. And these are basically mandatory for them. So even their suppliers have to manage or have to be compliant to such things. So this is going to be implementing, I am seeing in few companies we have talked to, including even electroplating and few other industries, where the automotive giants who are from not from India, they are pushing for sustainability. They're talking about sustainability credits and ESG score, etc. There is also a voluntary carbon market where we could probably, carbonly, we can purchase carbon credits. Now, this is a very sad story, because if we are emitting and we are purchasing carbon credits just to, balance the whole thing, that's not a great idea to be in. And I guess that's not a conscious effort towards the whole thing. What we need to do is basically develop our, reduce our emissions, thereby creating carbon credits who are ready to buy them. And the intersecting worlds is carbon and ESG. We talk about carbon and ESG. Is that it's a key part of the E, which is environmental, and company's carbon footprint and its strategy for managing it are central to its environmental performance and its overall ESG score. So it's very important that the carbon emission has to be low in order to be to reduce their or to improve their ESG score. And here is where the role of technology comes in. Of course, there are many various types of waste. We can talk about water, gas, and solids, and there are so many ways which we can talk about. But and each have their own technology. Like you have ZLD, zero electric discharge systems, to ensure that the water is not wasted; it is recycled. Similarly, the sludge removal and disposal or reuse or recycle, reduce. All this is going to be part of and the technology plays an important role in such things. And the strategic imperatives for businesses to thrive in this new environment, they must integrate carbon and ESG considerations, embrace transparency and robust data management. This is very important because this is about being conscious. Like Bhaskaran sir said, he himself decided to carry a cloth bag rather than a plastic bag. I always say that we should not cross the red line even if the traffic police is not there. That means that we are ourselves making a conscious decision about things. Not that because we are forced to do something, we are doing it. And we have to proactively engage with evolving regulations and market standards. This is very important also for us. Yeah. Now, what is the foundation stone for all this? Consciously, last probably 5 6 years or a decade, we have been working on this. But into 2021, when the Panchamrit pledge was done in COP26 summit, we talked about reaching 500 gigawatt of non-fossil fuel energy capacity. We meeting 50% of energy needs by 2030, but in the prime minister's address during the 15th August Independence Day, he said that the energy needs through renewables is already met in 2025, which is a great initiative and it's a great push towards that. But is this going to be enough? The point is that because we are growing nation, we are a growing nation, so and we are going exponentially. Like it's going to be quick and fast. You can see defense is now totally make in India. We have so many import conditions, the tariffs going up by US. So we need to start making so many things in India, and our imports have to be reduced, and we have to look at other export regions. So there is so much of challenges. So naturally, the energy needs are going to go up. So we need to sustain or even be better than what we are today. Reducing projected carbon emissions by 1 billion tons by 2030. Now, this is important because the industries are the major, probably the participants into this. So it has to be that we have to start from there, lowering the economy's carbon intensity by 45%. Now, the carbon emissions and carbon intensity are quite, they are complementing, but they are very different. So I will come to that next. Achieving net zero emissions by 2070, and that's quite a challenge because of our population and the amount of effort which we need to put. And I'm really seeing IWMA putting a lot of effort, and this session also, which I'm taking up consciously, I would like to address everyone who is consciously looking at this, and even not, they should understand that this is a need of the hour. These pledges form a comprehensive strategy for India to lead in global climate action. And now talking about carbon intensity means decoupling economic growth from emissions. So, which means that carbon emissions itself, you have to decouple the economic growth. So it should not be proportional. So I am putting up equipment, and if I'm increasing my capacity, I have to emit even that much. So if I'm emitting, say, this many tons of CO2, 1 ton of CO2, I put two more machines, I emit 3 tons. That's not the way. Carbon intensity, we have to decouple, which means we have to look at sustainable ways to reduce our emissions, even if we are increasing our capacity. Then transitioning to renewable energy, promoting energy efficiency, it is also important because many of our equipments are getting older. So we need to really consciously get into that energy efficiency systems. Adopting electric vehicles within the organization, climate smart agriculture. Um, just for example, if most of the industries, they have so much of open area. If they could start some sort of agriculture, even say drip irrigation or any such programs within their facility, it actually helps the whole ecosystem in the climate. Implementing carbon pricing policies like carbon taxes, supporting a circular economy that reduces waste, and utilizing digital technologies for better resource allocation. So this can help reduce greenhouse gas emission. Now, coming to the Indian carbon and ESG dynamics from the global side, a business imperative which is very much for us as a country. So we have made that commitment that we will be net zero by 2070. Now, this is a pledge taken, but we all have to work towards it. So the carbon markets, the newly established Indian carbon market governed by the CCTS, it is a mechanism for obligated entities to meet emission targets or trade carbon credits. So this creates an additional revenue stream for the company. So this is a very good initiative because, again, as I said, industries look at their balance sheet, their profit and loss, their investments versus their returns. That's more important because of the nature of the business. Being a business place, this is important. So this is something which is being established very soon. It will be very. I think it is being implemented, but it's not very used because, again, we have not been sustainable enough, or we are not induced sustainable practices within our organization to that effect. And then ESG integration, of course, we can see a lot of push in larger organizations where they have ESG analysts, ESG managers, especially some forces who are working on ESG. And there is always that Indian companies are integrating ESG principles. But beyond that, it's important to understand that the ESG, so the environmental, social, and governance. The environmental is also a big impact, which is going to help us within the social and governance. So it is a very important part that environmentally we have to be very conscious in setting up the systems. So waste to fuel projects are a tangible way to demonstrate a strong E in the ESG. And this will surely appeal the domestic and the international investors. Again, when we talk about ESG, it's not a buzzword or at all nowadays. It's really going beyond a buzzword. It is becoming a critical business requirement. And by saying that, we should not think that it's just a critical business requirement for the top management. It is a critical business requirement for every area where we talk about. Whether we talk about sustainability within a supply chain or a manufacturing or operations or maintenance or probably even in the financial circles, everything like Bhaskaran sir was telling that Reserve Bank of India is talking about their ESG and their sustainability practices. I recently heard about one IT company saying that it's the future. It's going to be that carbon emission per employee. So this is going to be a standard. That's really it's a extreme today for us, but that's going to be the norm. So when we talk about humans, the carbon emission per human, as to because every human is using certain things which also emit carbon, like during disposals or so this is going to be acted upon in future. That is going to be a mandate. Today it's going to be more about industry driven and our personal capacity what we can do. Um, and then we have this business responsibility and sustainability reporting. There are market and landscape and market mechanisms available. It's called the BRSR core framework. Then you have the CCTS scheme and the VCM market. So this is already available in India for us to take. And just for the information of all, I mean, if people are thinking it's only for the Tatas and Birlas, no, it's not. It's for every company, every factory, even if it's the smallest to the largest factory, they can take carbon credits. There are various ways of showing sustainability. Now, this coupled, see the external factors, the the available dynamics within India, the available dynamics externally, and the challenges in the industries. So, coupled with the challenges which we have in the industry, there is a rising energy demand. Surely, there is a rapid industrialization, rapid urbanization, infrastructure development, so much happening in such a small time. Everything is going fast. Metros are coming in. Metros, I mean, it's expanding, it's extending beyond Chennai, and many in the cities it's gone beyond the cities. So we are looking at the large, and the industries supporting this sort of infrastructure development, they are also coming up in a faster way. So the demand is projected to rise significantly in the coming years. Significantly will be really exponential. Now, what we do normally is, it's so easy for us. I have been meeting so many customers in my past few years, and since ever since we have got into sustainability, the first thing we talk about is that the easy use of the fossil fuels. Of course, fossil fuels are easy to use, and the dependence is because of the system which has been implemented based on fossil fuels. Now, we need to understand that that is not the norm. We think that's a norm because that is how we have been uh, taking it. So basically, if a machine is running on gas, it is running on gas. We don't talk about anything better. If a system is running on diesel, okay, fine, it's running on diesel, that's fine. So that was the norm till few years back. Now, with such conscious efforts, now we have started thinking of alternate fuels, which can reduce the carbon emissions and also help us in reducing our costs. So the fossil fuel independence is very very high, and in again the prime ministerial address in during the Independence Day, he was talking about reducing the imports of fossil fuel. So how is it possible? That is where we talk about the rural urban connect. I will talk about it in few slides later, but that is also an important point which we have to take for alternate fuels. Now, waste as an asset. This is the third important part. The energy challenges come from the misunderstanding that waste is not an asset. Waste is to be disposed. And we always talk about the three R's: reduce, reuse, recycle. But how much are we reducing at our end? Are we reducing the waste? Are we reusing the waste? Are we recycling the waste? We are recycling the waste to an extent. It could be, say, water recycling, but what about the sludge? How much are we reusing that? How much are So we will have to talk about that, and it is a valuable resource. Nature has made it that way. Nature, if you see, is a complete ecosystem. It's a cycle. It's a life cycle. Right from the source to the waste comes back, and it's again becomes a part of the source. We have to learn from nature and get ourselves into that system. Now, the other, I would like to talk about some myths. Basically, renewable energy, when we talk about, everyone talks about wind and solar. It is good. It's great. Technology is good. Again, solar is great. Wind is great. We are using natural resources for sure. But are we really looking behind the scene what is happening? And is this the only renewable energy which is available? Most of the industries talk about, oh, I have 10 solar plants, I have 10 windmills, so I am carbon neutral, I am sustainable, that's it. And then I will emit here. But that's not the point here. The energy which you are using, or you are keeping a wind energy or a windmill somewhere in a probably in a village, is actually changing the whole environment aspect of that village. We are not understanding that point of it. How about after a few years when you have to decommission? What happens to the? How do you dispose it off? Do we even see what is the LCA or the life cycle analysis have we done for a windmill manufacturing, where we use polymers, we use fibers for the windmill blades. So these are all things which we have to look right from the source to the sink, the last. We have to look at the complete thing, including the solar panels. They have so much of hazardous materials within them. We just think that okay, it is sustainable. Yes, it is sustainable, but for the first 5 years, we calculate the carbon emission right from the manufacturing. It takes 5 years for a solar or a windmill to actually get out of its carbon cycle and then give us clean power. So this is what we need to understand, and the water use is for CSTL, it's CSTP. The water for cooling is something. Hazardous materials of solar panels. So the carbon, it does not come without carbon footprint. And then the land use and habitat loss is something which we need to realize when we go for solar farms. So there are ways of going against it, like getting into it into mining sites, or in placing it in rooftops, abandoned sites. These sort of things we will be able to we should use in order to reduce the habitat loss. Wind energy, again, the same issues, land use and habitat disruption happens, wildlife impact, because more number of industries, we are putting more windmills without understanding that it is completely changing the habitat. It's improving, it's increasing the noise pollution. We are not talking about, see, there are noises which we hear, there are noises which we don't hear, and it could impact us in some way. So that also needs to be understood. Aesthetics and visual impact, manufacturing, right from there to the decommissioning, there is a carbon footprint. Now, so having said this, so industries where we say that we have solar, we have this, but we also have a very big, revenue stream in within our place. It is waste which is available in our place. Now we need to understand how to make it a fuel, and fuel to energy, and energy to money, and that's the whole purpose of this today's discussion. And waste to fuel pathways, there are two basic ways of fuel pathways. One is thermal conversion, where you use heat to break down waste, and the other is using microorganisms to process organic waste. So thermal conversion would be that heat, like you will combust it, you'll partially combust it, or pyrolysis, or various, there are various means by which you create thermal energy, and that thermal energy is used meaningfully into your system, into your manufacturing. The other is creating microorganisms into the, creating that reaction, and generating biomass, biogas, and bioethanol. So the goal of this is basically that we need to reduce our landfill waste, generate renewable energy, and lower greenhouse gas emissions. Going back to thermal conversion pathways, there are different technologies available today, and each technology will depend on what sort of waste is being emitted, and what sort of additional waste or energy has to be put in. So pyrolysis is one technology which is there for many years, of course, and this is basically the heating in the absence of oxygen, which means it will be something like a pyrolysis where the syngas, the gas is instead of combusting fully and giving the heat value, it'll generate gas, which is then used into burners or any sort of flame generators to generate heat, or it could be even run into a engine to generate power. So these are, and the outputs are bio-oil, syngas, and biochar. These are ideal for plastics, agricultural waste, and rubber. But today we are talking about pyrolysis with many more such materials. A lot of materials are coming under pyrolysis also due to the research ongoing. Then we have the gasification products process, where reacting carbon-based materials with controlled oxygen or steam, it generates syngas again. The syngas can be used for electricity or refined into liquid fuels. The third is the oldest form of heat energy conversion, which is incineration. So with incineration, we are able to produce heat, which will maybe you mostly used into boilers, and then boilers will generate steam, and then you can get into heat or generation of electricity. So the idea is that the in this, if you see that incineration has a slightly more environmental impact because of the high temperature incineration. You also have nitrous oxide NOx, which is emitted, and SOx NOx could be because of the various waste which can be coming. Then we come to the biological conversion pathways, where we talk about anaerobic digestions and fermentation. Where anaerobic digestion, the microbes break down organic matter, which is food waste, sewage, agriculture residue, or even the sludge in some ways, without oxygen. And it produces biogas, methane, and carbon dioxide for electricity, heating, or vehicle fuel. So this is one way of using the waste to energy, which is being used in many organizations. And then the fermentation, yeast, bacteria convert sugary, starchy organic waste into ethanol or other liquid biofuels. So, common for agro-industrial waste like molasses, fruit pulp. So these are the two ways of biological conversion pathways, and there are few more which are coming up in the years together. Now let's go to the fuel forms and their applications. Now, when we talk about wastes, there are different type of waste which come. One is a solid fuel. So solid is the municipal solid waste or a waste in solid waste generated by an industry. So that can be converted into reduced derived fuel, refused derived fuel, which is RDF, and it can be fed into either incinerators or kilns, or it could be fed into burners. And this is also a similar technology to what we talked about in the earlier stage. So normally, a lot of cement manufacturers are buying MSW or RDF to use in their kilns, and fuel farms and their applications. So again, liquid fuels, bio-oil and biodiesel can be generated from pyrolysis of biomass, plastics, tires used in burners or refined, and biodiesel from waste cooking oils, animal fats for diesel engines. So what happens is the idea is that we are talking about these fuel forms here. It's not that we don't know about it. The point I'm trying to make here is all this fuel or this is actually disposed of. We normally dispose it off so that we keep ourselves clean, and we think that where we are disposing, they are using it in a proper way, but that's not true. We don't know what they are doing. They could be also disposing it out, letting it into streams, putting it into landfills. So we have to consciously, as industry, understand that these are fuels which we can recycle, and we could either use it in ourselves or we could sell it outside as products. So in the market, and this will have a great ESG score and a carbon credits along with that. Then we talked about the solid fuels, solid waste, the liquid waste, and now the gaseous fuels through biogas and syngas. Again, this comes from the anaerobic digestion for power, heat, vehicles, um, and syngas for gasification, for turbines, even for chemicals. So we could also generate chemicals out of carbon dioxide, CO2 capture, and liquid fuel. So a lot can be done if we are able to, capture our energy, the waste, and convert it into fuel. So if you can see on the right hand side, there are various methods through which you can either generate gas, which can then be taken into electricity, or you can directly run a turbine out of that. So these are the methods where you could either have methanol production or syngas. The input would be biomass, coal, waste, steam, and the output will be steam, oxygen, air through gasification. Now, uh, the whole idea is that we are talking about circular economy, and it is very important for us as an industry that everything we use or we put to use, we have to make sure that it is recycled and it is reused. So there should be a certain circular economy we have to use, we have to put it to till it becomes utterly waste and it does not impact the environment. So this loop is very important. So we have to importantly close the loop. Now, the environment or the sustainability definition for many of us is that I'll reuse or recycle whatever I can and dispose the balance. But what we need to do is consciously even look at that and see what are the ways and means. There are technologies available in the market where these can also be recycled in various other methods. So we have to be very responsible in that way. We cannot just dispose of waste and say that now I'm clean. It is not so. We have to make sure that we close the loop. We understand that where our waste is going, are they really doing it? Are they really, recycling it? Are they putting it to use in a way which we want? Is there a way we can work on that and close the loop? We need to talk about it. And I guess associations like IWMA can help in such, closing the loop, understanding the waste which we have, and defining certain technologies which will help generate revenue as well as reduce the carbon, or reduce the waste disposals. And the circular economy integration is that moving beyond linear, which means the linear is take, make, dispose. We use that. So now from take, make, dispose, we have come to take, make, recycle, and dispose. Now we have to go from there to circular ecosystem where waste is resourcing industrial symbiosis. So industrial symbiosis is like nature. It is similar to nature where there is a life cycle. We need to start working at it as an industrial life cycle. Resource efficiency and waste valorization, assign value to discarded materials, reducing landfall burden. We have so many systems in our manufacturing. We have 5S, we have just in time, everything is there. We also need to have certain systems given to the value of discarded materials. We have to put so much effort towards that, towards auditing such initiatives, and making sure that we record it properly so that we reduce our landfall burden. We should be responsible enough to make sure that we are not, and we should declare that this much of landfill has been reduced from our end this year. Minimize virgin resource extraction and environmental impact. Are we really contributing towards that? We buy aluminium, we buy raw materials, but are we are said that okay, you buy, so we buy ABS pellets, for example. There are recycled pellets available in the market, but what do we do is after that, what do we do? Are we disposing it off, or are we reusing it into something else? Now we have to think about that. Now we have to also declare the how much we are reducing our virgin resource extraction and environment, and reducing the environmental impact. So India's significant industrial waste, because of the sheer size of it, is actually giving a massive valorization potential. Now this opens uh, a lot of revenue streams for many. This can be even an entrepreneurial idea. And there are some entrepreneurs who are starting up with waste to recycle. But again, the complete resource efficiency and waste valorization is still yet to come for us. And synergies with other sectors. Now, byproducts like biochar can be used in agriculture as soil additives. Just as sir was telling that plastic waste somewhere is being used by a textile or a company in Tirupur. Now this sort of synergy is very important. Synergy between rural urban, synergy between industries is very important. Now a waste of one industry could be an input to another industry. This is a type of cross link. If we are able to maintain, it is going to be a great ecosystem which we can create. Waste to fuel, again, it's a catalyst for circularity. So it is not the circularity, but it's a catalyst. So the first steps towards circularity is waste to fuel. So we talk about diverting waste from landfill. So that let's take up that as a challenge. Let's reduce the landfill. So what do we do? Then we go backwards as a backward integration, reduce environmental burden, and recover valuable resources. So once we see that, we see valuable value into the waste which we have, and then we have to transform the discarded materials into energy and new products, preventing the extraction of virgin resources, and then decoupling growth from resource depletion. And this is how we do the carbon intensity. We get into carbon intensity, where we decouple the growth from the resource depletion and also the emissions. Just take a break for some water. Thank you. Yeah. So, do we open for questions now, or at the last? Hello.
Yes, sir.
Uh, should we should we open up for questions now, or we can do it last after
It
the
should,
session?
after the session, we'll take a question, sir.
Okay, sir. Okay. Now we talked about waste to fuel, which is the catalyst for circularity. What is beyond fuel? So that is a broader circular benefits which we talk about. So what are those which we talk about are reduced carbon emissions. So we reduce the carbon emissions by replacing fossil fuels with waste derived fuels, which will cut GHG emissions. We provide opportunities, create jobs in collection, processing, and energy production. That itself is a revenue generator and a job generator. And sustainable material management, it promotes a systemic shift towards waste as a valuable input, not just a problem. So this is important that as understanding and information is shared across every department within an organization. We'll talk about the importance of sustainability, talk about material management in terms of waste management, not only just the input material or the output material. Now, we talked about the waste to fuel, beyond waste to fuel, that is the carbon emissions, and the understanding of sustainability within the organization. And the way forward for industries is embracing waste to fuel innovation. So, I hope by now we all are committed towards that, and we all realize that this is the way forward, whether it's a small company which is doing a small anything, even it could be a lab, it could be a small lab. We should not be thinking of emitting anything. We should see how we can reuse, how we can recycle. So this is how we need to look at the options individually as well as an organization. So, but for this, there is a lot of support required. Now, industries, as I said, are deriving. You have to derive benefits. Profit and loss is important. Balance sheet is important because we have to pay salaries. You have to take the business forward. So naturally, there, what is it in it for the industry to get into such initiatives? So the policy and regulatory support is required. There are some favorable policies, but it is not across and it is not implemented properly. So I think as an association, as large member organizations of CII, etc., we need to see if we could take this in a very serious manner and talk about circularity and implement policies which are favorable to that. Like yesterday I saw in the news that for carbon capture, now the government is offering 50% to 100% support on loans or probably financial support. Now carbon capture is a very important thing which I'll come to in the last. So these sort of policies and regulatory support, everything has to come. Financial incentives are required, subsidies, tax breaks for waste to fuel projects. Because without this, taking waste and reusing it, recycling it, or even talking about reducing it, there is a cost. Technology innovation is going on very well. So like we represent few Indian companies who are working on technological innovation for such sustainability, which is a great thing because imported is normally either you import from the West, which is very expensive, or we import from China, which is not below, it's below our standard. So we have our own technological innovation which is happening. We need to have more technological innovation within India to in this sustainable path to work on circularity, and that's probably for all of us sitting here, there is a big opportunity for all of us. And invest in R&D within organizations. What can we do to invest into R&D to improve efficiency, reduce costs, and adapt technologies for diverse waste streams? What is the government going to do about this? What policies can favor for such R&D to improve efficiency? focus on decentralization, modular solutions suitable for various industrial scales. So we can probably set up a large plant, but it will be like used at 30% efficiency. How about decentralizing it? How about making modular systems? So there are today technologies which are modular, which are customized to the customer's requirement, to the industry requirement, to the waste requirement, and so on and so forth. Industry collaborations and public-private partnerships, they encourage industrial symbiosis. Parks waste from one become the so one industry waste becomes an input to the other industry, and public-private partnerships to develop and scale uh, fuel infrastructure. Now, this is how we today talk about various things. There are so many stories which you hear that one company is taking up plastics and doing it, but right outside my window I can see a plastic heap. Now, it doesn't solve the problem. It doesn't tell the whole story. The whole story is that how do we actually take this as a challenge and completely change ourselves? It cannot be that one company is doing this. It has to be that every company is consciously doing this. And once that happens, probably I will not look at plastics outside my window, probably your window. It would be clean because everyone will be using it, and so the waste will be taken up. Tamil Nadu has started monetizing rack pickers to supply to industries, and so this is a great initiative. Now, implementation. See, policies are in place. How do we implement? How do NGOs work on this? How do industries take responsibility? How do individually we take responsibility for this? How do social workers work on this? This is going to help us aggregate the whole waste which is lying inside industries, outside industries, and use it as a fuel. The other day, I was in a discussion with a customer on sustainable alternate fuels, and we were asked a question that is there enough fuel? You're talking about today one company, but we are 100 companies. How do you think that the fuel availability will be? Now, it's all about how the environment grows, how the ecosystem grows. It's simple. It's all nature driven. If I have an alternate fuel, if I have a need, the supply and demand can be met. But more importantly, it can be met if we do not waste, we do not throw, we do not decompose it. We aggregate it and use it, store it properly, and we use it. The supply will be more than demand. After all, we are just a small part of the whole universe. I mean, as humans, we may be, thinking that we are the Lord of the Ring, but nature is bigger than us. Strategic pillars driving industrial waste to fuel adoption. So, this is one of the strategic pillar which we need to adopt, and this is the only way we can drive industrial waste to fuel adoption. So investment in R&D and infrastructure. This has to start from the larger organizations to the middle organizations because they can, benefit from that. And surely this has to be supported to their suppliers. So this has to be a sort of a understanding between, say, an automotive giant OEM has to talk about sustainability to all its suppliers. Of course, there are some MNCs who are already started doing that. They have started giving ESG scores, sustainability, but there is no clear indication of what to do. So what happens finally is people will start buying carbon credits and showing ESG score. But that's not the whole story. That's not going to be the actual face, the true face. The true face is there will be still waste lying in here, and it is not going to be used. So we need to invest on R&D and D and infrastructure for advanced conversion technologies and scalable facilities. Policy and regulatory support is very well required. Waste stream optimization, like waste sorting, collection, pre-treatment, all this is important. So we need to realize all that. We have to be skilled in that, and we have to take it forward. as I was mentioning earlier, that the only way for growth is collaborative, which means all of us collaboratively work together towards it. It cannot be one story or two stories or 10 stories. It should be everyone's story, and we have to forge a sustainable industrial future. Now, it's for benefit of everyone. If we feel that, okay, it's someone else's problem, then we are letting out an opportunity of making money, and it's a revenue stream which we are just throwing it out of the window, because someone is going to be get smart enough and start taking out your waste and reusing and making money out of it. So why not that you yourselves do it? And as it goes, there is going to be carbon credits and ESG scores, which will help your organization. And if someone else takes that benefit, it's not going to benefit you in any way. Now, so cross-sectoral partnerships, we have to foster collaboration between waste management, energy, manufacturing, and research. So the complete ecosystem has to be collaborated with education and skill development, building a workforce capable of managing and innovating waste to fuel systems. Basically, it's like, as simple as what Bhaskaran sir said, that carrying a cloth bag instead of a plastic bag. It's as simple as that. It is not so technically this that even a common man cannot understand. Sustainability has been part of our life. Everyone knows that. We do it in our houses. We just have to do it in our factories. Individually at our place, how do we make sure that we manage and we innovate so that the waste can become fuel and it can, help a larger objective. Measuring and reporting impact. It's very important because transparently showcasing environment and economic benefits to drive further adoption and trust. So today it's not a mandate. Today it's not something like quality, which is very very important. We talk about ppm, parts per million, 2 parts per million in automotive, and this is the quality. Just give me a minute. My battery is just draining out. I'll just get the charger. 1 second. Sorry. Sorry for this, but anyway, I hope you had a small break. Um so as I was saying that, the measuring and reporting impact is very very important for us to drive further adoption and trust. Yeah. So when we talk about the best practices, slashing carbon emissions, reduce carbon footprint, we talk about waste to fuel circularity, energy efficiency, sustainable operations, and sustainable reporting. So this completes this is the complete cycle which we need to take. So and it is a continuous process, which means that when the sustainability and reporting starts, this actually gives you an idea where we are, where you are, or where we are as an organization, and then how do we do get further into that. This is a sustainable cycle, which is again it's going to be for for a long time, because till we get completely carbon neutral, it's going to take a lot of iterations, a lot of changes within our organization. So this is something which we need to take, and reporting is very important. Without reporting we cannot get to the next level. Yeah. So for some more insights on the industrial best practices, let's talk about energy efficiency. So when we talk about energy efficiency, there is a lot of IoT devices, smart manufacturing, machine learning, and so many things which are AI. Everything is being integrated into making the equipments more energy efficient, and also the data which you get. We can actually make see the efficiency of the machine, see the utilization of the machine, and see how we can make it more efficient. So, implementing advanced insulations, for example, optimized machinery and smart energy management systems. This is being used by large organizations, but this can also be a good way of uh, approach for smaller organization as well. Because as we go forward, again, automation is going to be very important for us, though we are dependent on a large population. But I think with the skill going down on the operation side, it's very important that we go into automation. And once we go into automation, there is a lot of data which we can get, and we can actually analyze and make ourselves more efficient. Process optimization, redesigning industrial processes to minimize energy consumption and waste generation. So, what we do are small fixes like I get hurt, I put a bandage. But what about I put a guard itself so that I don't get hurt? So, that sort of thought process has to go into redesigning the industrial processes. So, this will help minimize the energy consumption and waste generation from the beginning. So for greenfield projects, it's important that we start with process optimization in the beginning. For brownfield, it's that the whole process has to be understood, like you do for some sort of project management or for some, certifications. We need to work on that consciously within our organization to redesign the industrial process. Then we talk about transitioning to renewables. Again, it should not be a push. It should be that consciously we have to go into renewables. And I do not throw solar and wind out of the window always, but it's something that you can do, but that is not the only thing you should do. We need to go and see what waste we can recycle, the bioenergy sources which we can use for our own electricity and heat. Though we may be wheeling solar and wind energy for our requirement of internal uh, electricity, and we may be still using electricity from TNEB, for example. But TNEB electricity is not coming from solar and wind alone. It is coming from fossil fuels. It is coming from coal. So what are we doing with respect to that? We are just wheeling and balancing it for our organization. But if we can use our internal renewable energy, which is the bioenergy or the thermal energy within our waste, and source and generate electricity, even if it does not save us that much money, at least we are doing something for towards the organization and the globe. Carbon capture, utilization, and storage. So, exploring technologies to capture emissions from industrial processes. So, this is again a very good initiative which has been going on for some time. And we are also working on some carbon capture initiatives where chemicals can be, generated using carbon capture, which can be reused by the organization or it could be traded with some other organization. This is a very important part because carbon dioxide emission, most of us we talk about within the PCB norms, the pollution control board. There will be norms, but that itself is a waste which can be used. So we can go to that extent where we can convert that into certain energy. Talking about the fossil fuels which we normally depend on, I would just like to give some numbers here, and these are numbers from the net only. So, and this is from the open market. So, in various factors, we the carbon dioxide emission. If you see for say different fossil fuels, I talk to many people in the organizations. They say gas is clean. Is it clean? It emits 2.9 kgs of carbon dioxide per kg of fuel burned. Is that clean? Clean in the sense for energy it is clean. But as a fossil fuel, it is not clean. It is a fossil fuel at the end of the day. We are emitting carbon. So I think most of us know what is carbon emission in the first place, because carbon emission doesn't mean that I'm taking carbon dioxide and releasing. No, carbon emission means I'm taking from the ground source and I'm releasing it into the environment, which means I'm adding carbon to the environment where the environment is already sustainable. Like plants, they capture carbon dioxide, they release carbon dioxide in the night. So when we use plant-based energy, like we use biomass or we use agri-waste, they are carbon neutral, because the carbon which is captured is being emitted, probably not even to that effect, but still it is carbon neutral. Whereas what we use in fossil fuels is carbon emission. So this is a big thing which we need to know. Now all of us can calculate how many kgs of LPG or diesel or what we are claiming. So how much of carbon dioxide are we emitting every day? We are doing scrubbing, we are doing various patterns. We are having a, we'll say we have a tall, chimney. We are taking care as per the PCB norms, but the reality is that there is emission. So, and okay, that's one side. So that may not be very, disturbing for people. But what about the price increase? We are talking about price today, but what about tomorrow? Today you have BRICS, you have different wars going on. There is a lot of discussions, tariffs, and US putting tariffs on us, and so many things are happening. We don't know how it is going to be influencing. It's a volatile situation we have. So the fossil fuel imports is not in our hand. We are dependent on foreign soil. So that is going to be something which, if India is growing, no one wants us to grow. So naturally, there will be hostility, and that will intend. They will try to, power is the biggest thing. Energy is the biggest thing. They'll touch there. They'll increase our prices. We can't do anything. So difficulty in sourcing is there also. Medium to high, you can see diesel is high, LPG is low to medium, fine. LPG is available. So cause of difficulty in sourcing is global shift from fossil fuels, with many countries seeking alternatives, especially in aviation and heating. And if you see in furnace oil, a pervasive lack of investment in oil exploration. And if you see in diesel, a global supply shortage caused by refinery closures, production cuts by OPC and seasonal refinery maintenance. LPG, you see, sourcing is generally stable, but challenges existing in managing a cylinder supply chain, distribution, logistics, and now the carbon dioxide emission. I'm talking about only just the gas emission. What about the supply chain carbon dioxide emission? We're talking about the supply chain emission as well. Similarly, for CNG, infrastructure limitations, and PNG, again, same thing, particularly in rural areas. Coal, while we are having the largest domestic reserves, sourcing can be difficult. We are also dependent on imported coal because it is having low ash content for our boilers. So, but again, we are dependent on imported coal more than our Indian coal, because Indian coal has more ash, it has got more oil moisture. So we use imported coal. So the again the costs are changing, and the inefficient supply chain is there, and environmental concerns naturally in holding it, buying, purchasing, storing, and then using it is a big challenge. So I just wanted to give you a flash on what the things are changing towards today in India. There are some technologies which are developed within India who basically are working on agri-waste pellets. For this is an example of a burner developer from Chennai, IIT Madras, where the agri-waste or refuse-derived fuels are used to convert into heat energy or into steam. So on the above, you can see this is nothing but a product which is used for kitchens, community kitchens, where they are using LPG. This is a very simple and efficient system which can, with less smoke and less emissions, it can actually give the same energy as an LPG, and you can use it, and it will at least give you 30% savings overall on the overall thing. The only thing is that the supply chain of the pellets have to be managed, which is being managed. But these sort of systems, and the second where you see is a a boiler with the pellet system, pellet again, the agri waste pellet system, where the burner is placed below, and the agri waste pellets are gasified and burned into the boiler, and then it gives steam for the kitchen. Now, these are basic things which can be integrated into every large organization. This is the basic thing we should can even start with. Why should we start? Maybe people are thinking, okay, this technology, if I put it into a heat treatment furnace, how effective will it be? Fine, but can we not use it for a kitchen purpose at least? And reduce our cut our consciously cut our cycles. Can we not promote such technologies to industries where this is and again LPG is being wasted, because LPG used for that purpose, you can use this as a better purpose and you can still save money. So, and also we are reducing carbon emission, because as I told you earlier, agri waste is basically, if you leave it for decomposing, it will generate methane gas, which is very, very harmful for the environment. If that waste is pelletized and used in a burner, we are actually using waste to energy. And the waste to energy, what it does is it is reducing the carbon dioxide emission, and whatever carbon dioxide is emitted is basically making it carbon neutral, because agri waste takes carbon, plant takes it and releases it, so it's carbon neutral, and it directly substitutes traditional solid, liquid and gaseous fossil fuels. So these are some products which are there from the technology, and they've automated it. And we have issues on industries whether how can we, we need to have manpower. So it's a complete automation system which is there, and also the gasification systems are available. And there are certain products which are available, and the burner itself which can take care of, or it can take care of just the PNG, or it can take care of that. Now, we though we talk about energy as from the that source, we can also talk about RDF pellets. So again, if the municipal solid waste, the solid waste is available, this can be actually converted into RDF pellets, and it can be directly fired into for used into your heat treatment, or for your drying purposes, or for your various other purposes where heat is required. Now, if you see that it is a direct alternate to natural gas, LPG, diesel, coal, and other, industrial fossil fuels, the GCV is quite high, which means that for right from 4,500, which is probably coal, has that GCV, up till 7,500 can be achieved based on the type of RDF which you're talking about. So it is emission is 40% lower emissions compared to coal, low carbon alternative fuel, and it's an import substitute directly. And it also meets the G3 coal standards. So it has got low ash content. And I would like to give some examples, numbers in terms of price. So if you're buying LPG and the cost of fuel is 1 rupee, and in rupees is 97 rupees, and calorific value is kcal is 11,800. The agri pellet cost equivalent is 59 rupees for that 97, which means there is a direct saving of 38 rupees per kg of gas and 39 of diesel. So you can calculate how many kgs per hour you are actually consuming. That is the amount of money we are losing if we don't get into this sort of technologies. The other technologies which we can talk about is biohydrogen production, where waste plastics and wood waste can be through pyrolysis and a series of manufacturing. You can get into hydrogen. You can create biohydrogen or green hydrogen, which is the talk of the this, and it is being welcomed by government, and a lot of uh, good policies are there towards that. Now, there are industries which are helping through this. We can also support you with some information on that. And the other the biohydrogen production from biomass, where you could use this purified biohydrogen for various applications like fuel cells, semiconductor, food processing, metal processing, power generation, and chemical industries. So, from the biomass, the possibility of capturing carbon dioxide and hydrogen, and then you capture carbon dioxide. This carbon dioxide can be used for generating certain chemicals or certain byproducts, and the purified biohydrogen can be taken into various other applications, which I just talked about here. So, these are this is how we can create an ecosystem. As I said, these were small examples because it takes a lot of effort and things to talk about many more industries. And because I know that in IWMA there are various industries, right from plating to textile to automotive to metals, steel, and pharma, food, everything. But the waste from all of us, all these industries can be recycled, and the main waste which comes out of all this is carbon dioxide. Carbon dioxide capture can be done to use for meaningful fuel, that can be done, as well as we can talk about solid, liquid, and gaseous form of fuels, which can be converted into energy. And we can talk about the the thermal and the bio way of converting waste to energy. So we as a company, just a introduction of ours, we represent few technologies within us, and we our motto is to ignite a greener future. And this comes from the fact that we work on manufacturing sectors, where we give manufacturing sectors, and we forging the future of industry. We are your partner in navigating the complexities of modern industry. So our mission is to provide cutting edge solutions and state of art equipment. And as I have 28 years experience in the industry, I have addressed various industries, various technologies. I have worked on new technologies like gasification and additive manufacturing, etc. I've been also with combustion technologies, and also part of product development and few other initiatives in my early the services we offer is equipment software supplies for manufacturing applications, consultation on sustainable technology and efficient manufacturing practices. We also could undertake energy audits for your energy requirements, implement turnkey projects, supporting on implementing green ocean strategies. It's a very important concept because we talk about blue ocean and red ocean, where red ocean is mainly products, blue ocean is solutions, but green ocean is a complete circularity. Business with circularity is green ocean, and economic empowerment through science and technology. Our services are we supply combustion systems that enable heavy industries to replace fossil fuels, even smaller industries. We can talk about carbon capture utilization technologies. Just to give you an example of carbon capture, it can be used into converted into methanol, methane, syngas, formic acids. I've seen in many industries they use methanol. So there can be ways of recycling and getting methanol for their industrial uses as well. Syngas, formic acid, even building materials through a process called mineralization. So carbon dioxide can be captured, and through mineralization, where it reacts with metal cations to form stable carbonate minerals. And you can talk about limestone, aggregates, concrete blocks, other carbonated building materials, and even indirectly for polymers and plastics, polycarbonates, polyurethanes, and industry and fine chemicals can also be developed through carbon capture, urea, formaldehyde, acetic acid, etc. So I would like to conclude here. I think I'm before time, but we have time for question and answers. So feedstock could be anything. It could be municipal solid waste. It could be industrial bio waste. It could be wastewater sludge. It could be animal manure. It could be agriculture biomass. It could be even waste food from the canteens. It could be anything which can be converted through a biogas plant or through a thermal plant, into usable energy, which can fuel your vehicle, can be used as industrial gas, can for make electricity, can also make fertilizers, can be used for heating, kitchen gas. A lot of ways of circular economy, creating that circular economy within ourselves, our organization, and it can also help the whole environment in the long run. So I would like to conclude saying that current model, we have this linear model of take, make, and dispose. But what we should do is make waste. The waste is taken up. We need to convert it into sustainable landfill. Sustainable landfill is where it is not impacting the land, but we are creating that landfill because we have to store it and then use it for various applications like land use, energy, and landscape conditions. So this is how the sustainable circular model looks like. Uh, so let's ignite a greener future together. We have a blog on sustainability as well, which you can visit, and you can reach out to us on these numbers and email IDs. And I would profusely like to thank IWMA for this excellent opening for us to address the organizations, industries, uh, about a very, very important part. It's an important subject, which is sustainability and circular economy. Thank you very much, sir.
Thank you, sir. Thank you for your session. Dear IWMA members, you can ask any questions in chat box and also on a speaker.
Sir, good evening. This is Dr. Anandam from CTS Petrochemical Manali.
Yes, sir.
Good evening.
Good evening, sir.
Good evening. It's an excellent topic you are shared with me. So
Thank you,
it's
sir.
amazing. Sir, we have that one
Thank
of the issue. For using the ETP, using that UTP by ATFT, some collection of solid waste. The solid waste containing sodium sulfate.
Okay.
This is not 100% pure. How to solve that
Understood.
material, sir?
Okay, sir. So, are you segregating sodium sulfate separately, or it is part of the whole
It comes
waste?
from that ETP.
Yes. So, are you segregating it in any way? Are you removing that separately, or are you purifying it?
Not purifying. Whenever comes that material, we collected some back. We keep it as
Okay,
ideal
sir.
now.
Okay, sir. So, is it important for your whole process, sodium sulfate?
Yeah, the byproduct is sulfuric acid. The traces has
Okay.
come. We can utilize by using that neutralization of sodium hydroxide. It forms the sodium sulfate.
Okay, sir. So you would like to reuse
Dispose of
this
the
or
material.
probably disposal.
Yeah.
So yeah. So what we can do is we need to understand how to get this into a purified form, and this could be input for any other industry, which we need to find out. So sodium sulfate can be input or could be a requirement for some industry or for some applications.
So
So
okay.
that can be looked up. I'll take
Okay.
note of this, sir, and if we could work on this, I think yeah. So also, yeah, as Mr. Janardhanan has said, it can be sent to co-processing for waste cement plants, but also the individually these sort of minerals or materials can be, it can be removed and it can be used for some inputs.
Okay. 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 Thank you very much, sir, for kind information.
Thank you, sir. Okay, I think some. So I think there are questions in the chat like how can ETP organic and inorganic and ATFD sludge be converted into fuel? Normally, sludge has high water content. Once we remove the water content, we can separate the organic and inorganic waste, and then based on the composition, we can decide on how this can be converted into fuel. It depends on what sort of waste is available. In organic phase, normally we can use it as an RDF, as a refuse derived fuel into heat energy. So there are burners available which can take in RDF and they can actually generate heat. The organic side, we have to see how we can, again reuse and recycle. Yes, sir. So, Mr. Sitaraman talking about carbon capture. So, this basically carbon capture is at the area where there is at the place where the carbon there's a emission where the gases are going out. From there, we can capture the carbon and we can actually uh, take it back, and into inducing in certain chemicals, we can create some sort of chemical composition which can be used for further use. So based on the requirement, it can be developed. So carbon capture can be used into various applications. Phosphate sludge be converted into byproduct? Yes, again, sir, these are specific questions where how can be answered, but we will have to first visit and understand, and then we could probably take care of that. And so this is so insulation waste. Yes, there are recyclers available for cow wool, rock wool waste, stone wool, glass wool. Yes, that can be part of inorganic waste. So that can be converted into energy using RD. It can be converted into RDF. And fate of industrial landfill and accumulated textile salts in textile industry. Yeah, as I said that the industrial landfill has to be reduced by going for recycling and reducing. First of all, we have to reduce the waste. We have to do it's like carbon intensive. We have to be carbon intensive. So, where we have to decouple ourselves from the expansions. The carbon emission should not be equal to the carbon expansion, the expansion of the industry. So that way we reduce and then we reuse and recycle. So the recycling is the most important part where there is very little understanding on various things, because as I can see the lot of examples here right now, there's so many different type of waste coming out. Now it's very important for the association like IWMA and a few of us who need to understand that, work together and give a solution for that. That's correct, sir. So solar panel recycling is also not allowed, but there are some organizations who are now coming in, who are setting up plants for these sort of even batteries, solar waste, etc. They are setting up plants to recycle those wastes. So I hope I have answered every question here, sir. Any more questions?
Hello, sir. Hello.
Yes, sir. Thank you very much. Yes, sir. As Veerapandian sir, surely it can be addressed. So please connect and we can discuss about this.
Thanks, sir. Thanks for your roundup section. So I thank Mr. Rajesh sir for enlightening speech about waste to fuel igniting greener future and slashing carbon emission. We really appreciate you on behalf of IWMA, Office Barrier, FUL members, senior manager, and participants. Once again, I thank all participants and our members. Thank you, sir.
Thank you.